This is just a quick warning. This video is quite a bit longer than the others, about an hour and 40 minutes. So of course it'll take more than one class to get through it, or you may not want to even view every single problem. All I do in this review is work problems. And unlike instructors, I come with a fast forward, so how much time you actually spend on this is up to you, but wanted to warn you ahead of time, this is quite a bit longer. Hello. Well, congratulations. You made it all the way through Chapter 1, where we discussed foundations of geometry. And foundation is actually a good word for it, because we learned about points, lines, and planes. Remember, these are the undefined terms, which we use to define all the other terms, which means they are the basic bricks from which we are building this house called geometry. So foundations is a very good way to describe it. We also learned about segments and congruence and the difference between a line and a segment. I frequently get them confused, but I'm sure that you have no trouble at all. Midpoint and distance formulas. Remember those? We're going to go over those. Measure and classify angles. Then we described angle pair relationships. We classified polygons. And at the very end, some really cool, useful stuff on how to find perimeters, circumferences. Maybe it's circumference. Well, let's try circumferences. And area, or areas. Now we're going to review it all. And we're going to do that by way of working out sample standardized test problems, after all. One of the things this class is supposed to prepare you for is the standardized test. So for a review, it seems to me that using a standardized test would make sense. Well, it's a sample standardized test. It would be really cool if we could use the real ones. Then you'd fly through the test. But no, we can only use samples. You don't get to know which problems are going to be on the standardized test ahead of time. So let's get rolling. Here's a good problem. They've described it one way. Sometimes these type of problems are described a little bit differently. So I'm going to work it the way they presented the problem. Then we're going to do it again with a slight change, because you're going to see it both ways. First I'll show you the way they've written the problem. And there's nothing at all wrong with the way they've written the problem. It's perfect. There are two ways to do this. This is one, and you're going to see a different type of problem, possibly on the state tests, or maybe later on in things like financial literacy. They say here that it costs $2 a square foot to refinish a hardwood floor, if the area is less than 300 feet. $175 if it's greater. In other words, they're giving you a volume discount. It's a little bit less if you buy more. That is per unit. How much does it cost to refinish a rectangular floor that is 6 yards long and 4.5 yards wide? Explain your reasoning. That part always annoys me. I think your instructors are going to have to tell you what they consider acceptable explanations, because on these standardized tests, the verbal parts are normally, in my experience, graded by your teachers, not necessarily the one standing in front of you. They may have to get handed to other teachers in the school, but it'll be your teachers who evaluate these explanations. Personally, the way I see it, if you get the algebra right, that is the explanation. These tests, you have to remember, were the whole idea was designed by lawyers and bureaucrats, so they may not get algebra. Normally, I would say, if I write 3x equals 6, therefore x equals 2. As far as I'm concerned, there's nothing left to explain. If you don't know why that's true, you shouldn't be evaluating students. But yeah, lawyers and bureaucrats, they might have trouble with this. I can understand that. So for some reason they want you to go through some kind of an English explanation. Yeah. Verbal stuff in mathematics isn't worth very much. It's all in the equations, the theorems, the definitions, the axioms. Talk is for people who major in English and history and that sort of thing. You can talk around things. I've actually seen questions like this in explanations. In fact, many students will speak the way they hear people on television speak. People who are very imprecise and barely have any idea what they're talking about, like journalists. So they'll start it with things like, well, I would say, or I believe, and those kind of expressions have no business in mathematics. It is or it isn't. What you believe is kind of irrelevant. What you think doesn't matter. What's true is what matters. That's all mathematics is. It's right or it's wrong. Don't ever start an explanation with, well, I would say, or I would think, or, well, I believe. No, that's for people on TV. Don't try to learn anything from those people. If they know anything, they wouldn't be on TV, right? So what are we doing here? First, we got to figure out what the area in square feet is going to be, because that's what most of our information is given in. Is it more or less than 300 square feet? Eventually, we're going to have to figure out the cost. So if the floor is 6 by 4, and it never hurts to draw a quick little picture if you want to. Remember, they say it's rectangular. We'll just pretend that's a rectangle. Wow. That is so bad. Now, 6 yards. So what does that mean? Well, let's label it directly. That's 18 feet. Just put a little mark up there for feet. I think I used that in the previous video, or that's for feet and that's for inches. It's a nice quick shorthand. Down here we get 4.5 yards. So that's right. 4.5 times what? Well, times 3, of course. 3 feet in a yard. So that's 12 and 1.5. Should be 13.5 feet. Now, to get the area in square feet, we have to use these two numbers that we just computed, not what was given, which was yards. And as you know, we could have computed it in yards and then multiplied by 9. You can do it either way. Frequently, I just convert to the units I want up front. Then I don't have to worry about maybe getting in a hurry and forgetting that I needed to convert at the very end and then grabbing the wrong answer. Get the important part done up front. Let's see, that's equal to 13.5 feet. So what we have here is 13.5 times 18. Now, according to my calculator, that's 243. And I would say, I bet you would too, that is less than 300. Which means we got to pay the higher price, $2 per square foot. So how much is it going to cost? Well, multiply 243 square feet by the $2 per square foot. And what do we get? 486 big bucks. That's not real expensive. On the other hand, it's not a very big floor, is it? Explain your reasoning. Well, like I said, check with your instructors on what kind of explanations they accept and don't accept. As far as I'm concerned, algebraic equations are an explanation, if you know how to read them. And if you don't know how to read them, why in the world are you grading a math test? So the explanation might be, first you have to find how many square feet this is, and then determine if it is greater or less than 300, which tells you whether to multiply by 2 or 175. Perform the multiplication, and it should give you your final answer. I guess you could write something like that, but like I said, I was a math major. I'm into equations. Words, they don't work with mathematics all that well. equations, they're perfect. Well, there's a good problem. We're going to use our midpoint and distance formulas. That'll probably be it. I keep saying these are good problems. Well, they are good problems, but I know I'm starting to sound like the narrator on one of those fishing programs. You ever watch those when they're out in the boat? The only thing he can ever say is, "and another nice fish." Well, here's another nice problem. They want us to find the midpoint, and they're using lots of words here to try to help you get confused. I mean, if they just written a grid and said, we got point L and point T, and here's the coordinates, find the midpoint and the distance from the midpoint to an endpoint, well, that would be a math problem. Now they're trying to do it in words. Don't get confused by all that. They're not saying anything more than what I just said. We've got a point T, a point L, and we're going to find the midpoint and the distance from the midpoint to the endpoint. So, libraries, town halls, I mean, maybe this is a crack house, maybe this is the fire station, and maybe there's a police station right there in the middle. What difference does it make? It's all just about finding the coordinates of the midpoint and the distance to the endpoint. That's all you have to focus on. So what is the coordinate of T? And this is kind of a small drawing, so I'll probably redraw it over here. It looks to me like T is 1, 1. Okay. And L. That looks to me like -2. And -4. Let's not forget our midpoint formula. Remember? X sub m. The midpoint, the x-coordinate of the midpoint is x1 plus x2 over 2. So let's try it. 1 plus or minus 2 over 2. Well, that looks like -1/2 to me. That is x sub n. On the other hand, 1 plus -4 over 2. Well, that's -3 over 2, I would say. And that's y sub m. So the coordinates of your house, halfway in between, are x sub m equals -1/2, that's right there, and -3/2, or 1.5, which is right there. And one thing we have going for us as we compute this as a way of checking, the midpoint, the coordinates that we computed for the midpoint does in fact seem to lie on the line. If we got a midpoint over here, coordinates to put us anywhere off the line, we'd have to know we made a mistake. The midpoint is definitely on the line. So now we have the midpoint. Now there's two ways we can compute the distance. It's up to you. I think I'm just going to use the endpoints to compute the distance, because the midpoint by definition is halfway between. So we don't actually have to compute the distance from, call it h to t. We can just take L to t and cut it in half. And it just looked to me like the arithmetic might be slightly less sloppy. Suppose we do that. We'll take x2, and let's not forget our distance formula. That's x2 minus x1 squared plus y2 minus y1 squared. And we're going to take the square root of that, and that is our distance. Right So let's try it over here. Minus 2, minus 1. We have to square it. Plus minus 1. Wrong. That's just a plain 1. Minus 4. That's what I was trying to say. Minus 4. Minus 1. Minus 2. Minus 1. Minus 3 squared. Well, I would say that's 9. Minus 5 squared. That's 25. We need the square root of that. Well, 9 to 25 is 34, pardon me. Square root of 34. And this, of course, is the total distance, LT. And we want half of that. We want HT. Or HL. They have to be the same. Square root 34 divided by 2. Now you can use your previous algebra and say that this is the square root of 34 divided by 4. Or you can just whip out your calculator, which is what I'm going to do. Calculators are allowed on most of these state exams for most of the problems. Here and there you're going to find problems where it says great big letters up on top. Calculators not allowed. But most of the time they will let you use your calculators when you're doing stuff like this. Well, I get 2.9, which means the total distance is about 5.8. You can take a quick look and see if that makes any sense. For instance, we got the 0.11 here, and we're down here at minus 4. So 1 to 4, that's about 5 units, right? And of course, whenever we deviate off the straight vertical, it's going to add a little bit of distance here. So 5.8, yeah, makes sense. If we'd gotten some weird answer like 10, and then half of it was 5, we'd have to redo this. But it never hurts to just take a quick look. Does nearly 6 make sense for the length from L to T? And the answer is yeah, it does. There's 5 units there and over about 3. So as you get better with the Pythagoras theorem, which you haven't even learned yet, you'll get much better at spotting whether these geometric answers make sense. But for now, just take a quick look. If it makes sense to you, then at least you know you've got a good chance of being on the right track. And another nice problem. This is cool because it's the way you would do physics problems also. In fact, a lot of these are the step-by-step, multi-step problems. In science, chemistry, physics, most of the hard sciences, you're going to have to use step-by-step solutions. You're going to do a little bit of math. You're going to have to incorporate your physics or chemistry equations into it. And then it'll be multiple steps. And this is excellent preparation for that sort of thing. So let's get to it. What do we have to figure out in this? Well, what's the question? How much water would evaporate in 1 year? Okay. So what we have to know is the evaporation rate, and we've got that. But it's in square feet. So we're going to have to figure out how many square feet this pool is. remember, don't ever just accept what they give you. In this case, we could multiply 3.5 by 7.5 and get ourselves confused and possibly come up with a wrong answer. Let's just convert to feet right off the bat, so there's no chance of getting anything wrong. So we multiply by 3. We get 9 plus 1.5 equals 10.5 feet. That's not cubic feet, that's just linear feet. That's the length of this side here. And this one here, again, we multiply by 3, and we get 21 plus 1.5 equals 22.5. Now that we have the dimensions in feet, computing the actual square footage of the pool is very simple. In fact, this part even a lawyer could do. There we go. So my calculator says this is 236.25 feet. Square feet. It's frequently written like that, feet squared. Even though we say square feet, we write feet squared. Why did we want this? Well, we want to know how much water we actually lose in a year, just through evaporation. So we're going to have to take that number and multiply it by 17.6, because that's how many gallons of water is lost per square foot. In fact, we could write it, if you're studying science and you're getting into dimensional analysis and keeping your units straight, you could do it like this: 236.25 feet squared times 17.6 gallons per square foot. Why would you want to do that? Well, that's one of the cool things about dimensions. If you keep them, carry them along when things start to get confusing, you can cancel them as if they were numbers. And our answer is going to be in gallons, which is exactly what we want. We want to know what the evaporation is in 1 year. And they didn't ask for the evaporation in cubic feet, luckily, because they didn't give us much cubic foot information. And if they asked for that, we would have to convert these gallons to cubic feet. That would be a pain. But we could do it. But we're not going to, because they didn't ask us to. My calculator says that is 3,449.25 gallons you lose every year. I don't know how many gallons a standard swimming pool holds. That's a lot of evaporation. I wonder what percentage of the actual pool that is. For instance, would you have lost half the water in the pool after a year? Oh well, they didn't tell us, so I guess we'll never know. Unless you have a swimming pool, in which case you can perform the experiment. Don't cover your pool for a year and don't fill it and see how much you lose. And then let me know, will you? Because I'm curious. Remember the first problem we did? And this turned out to be 230 something square feet. So we had to pay the 200 per square foot cost. Now, and they said if it goes over that, we get our discount at 175 per square foot. There's another way that problems like this are sometimes worded, and that is it's $2 per square foot. Sometimes they'll word these problems a little bit differently, and you have to pay close attention. Here, if we had, let's, for the sake of working this problem differently, let's suppose that this thing was bigger. I'm not even going to worry about the dimensions. Let's say that we just wound up with 425 square feet. And suppose the problem had been written this way: $2 for every square foot under 300, $1.75 per square foot for every square foot over 300. The way the problem was first written, if you go over 300, you get the discount for all the square feet that you buy. Sometimes it doesn't work that way. Sometimes you pay $2, you pay the high price for the first 300, and then you get a discount on everything over the 300. I'm only doing this so that you will be sure to notice which way the problem is stated, because I see students get this wrong over and over and over. I don't know why they tend to overlook this part and just pick one or the other. In this case, we have to do it two different ways. We have to charge or pay $2 per square foot for the first 300 feet. So that's $600. Let me just put it down here. I think you can do that in your head. 2 times 300. That's $600 for the first 300 square feet. What about the next 125 square feet? Well, that's different. We have to multiply 175 by, and where I get 175 is subtract 300 from the 425. This is in dollars. That's the $1.75 for 125 square feet. So let me rewrite this stuff here so it makes more sense. That's 125 times $1.75. And our answer, of course, will be in money. And my calculator says that's 218.75. So if we add it all up, we get 600 for the first 300 square feet. 218.75 for the last 125. So what do we got here? Well, see, this problem is here you pay just one price depending on whether it's more than 300 or greater than 300. If they break it up this way, there are two separate prices which have to be added up. Here's the price for the amount, the part that's greater than 300, and this is what you pay for the stuff that's under 300. And you add it up and you get this. I had to pick a number that doesn't actually correspond to 6 yards by 4.5 yards, because that number was too small to demonstrate what I'm talking about here. So when you're doing these problems, all I'm saying is pay close attention to which way they worded it. This way, or the way this problem is worded. I wouldn't mention it, but I've seen it done wrong. Well, I wouldn't say more often than done right, but it's about 50-50. So it's worth filing away in your brain. Now here's actually a practical problem. In this case, they're making swimming pool covers. I'm guessing the people who wrote this book live in California. Most of the world doesn't have swimming pools or even know anything about them. But you would use the same reasoning, for instance, if you were making bracelets and putting beads on here and you knew how big the bead was. You'd still have to compute the circumference and figure out how many beads per bracelet, so you know how many beads to order. You don't want to order too many and throw your money away. You don't want to order too few and come up short. You want to get things right. And this is what these people are going to do. They don't want to order too much material. On the other hand, they don't want to come up short. So they went and found somebody who knew how to figure out the area of a circle and asked him. Someday that might be you. Here they're designing the cover for a circular swimming pool. They give you the diameter. It's 20 feet. Or 25 mil. It doesn't sound right to me. Let me check this out here. That image looked like a round swimming pool to me, but that image was not designed to go with this problem here. This 25 millimeters has absolutely nothing to do with 20 feet. The diameter of the pool is 20 feet. So, yeah, let's draw a circle just so we know what we're talking about here. So, there's a circle with a diameter. Yeah, let's write a 20 in there. 20 feet. How much will it cost the company to make the pool cover? Now, obviously, what we're looking for here is the area of the circle. If it's not obvious, then I'm telling you, we need to find the area of this circle here, because that's what the pool cover is going to do. Actually, pool covers are probably a little bit bigger than the pool, but they're not taking that into account. I mean, it seems to me you'd have to add at least an extra foot here for being able to tie it off or setting weights on it or whatever. You don't want to just come right to the edge and stop. Let's not worry about that for now. And what kind of a formula do we have? Well, let's see here. We've got pi r squared for the area of a circle. But they gave us the diameter. But isn't it true that the diameter equals 2 times the radius? Or r equals d over 2? In which case, over here we can say r equals 10. So the area of the school is pi times 10 squared, which you really should be able to do in your head. That's 100. Pi times 100, which is 314. Remember, pi is 3.14. Multiply by 100, you just move the decimal points over. So we have a 314 square foot pool. They charge $4 per square yard. Uh-oh. We did all this in feet, but we needed this in yards. How many square yards in a square foot? Remember that? It's 3 squared, or 9. So first we're going to have to divide this by 9, aren't we? To get this into square yards. Or, suppose we didn't do that. There's another way we could do it. If it's $4 per square yard, then it would be 4 times 9, or 36 per square foot. How would you like to do it? Let's convert this to yards. We could do it both ways. What the heck? We're good at this. 314 feet, square feet, divided by 9 square yards. So my calculator gives me 34.9 square yards, and we have to multiply that by $4 per square yard. And let's see what we get. And I get, this is dollars here, $4. So $139.60 is what I get. All right. The other way to do this is to compute the cost per square foot, which would be 9 times $4, or $36 per foot squared. And if you believe that, you'll believe anything. It couldn't possibly cost more per square foot than per square yard. A square foot's way smaller than a square yard. So what did we do wrong here? There are 9 square feet in a square yard. It's $4 per square yard. What should we do? We should divide 4 by 9. We shouldn't multiply. 4 divided by 9 times 314 square feet. Let's get a little more room here. We don't even need to convert these to decimals quite yet. I mean, who knows? Maybe 314 is divisible by 9. Let's see. And in this case, we get $139.55. Why is there a nickel difference? Well, we did some rounding. This wasn't exactly 34.9. And I used 314 square feet. That's right, but with the rounding, you're going to get things like that. Especially with money. It'll be a few pennies different one way or the other. This is, in fact, close enough to convince me that we did it right both ways. We could take the square feet and multiply by 4/9 of a dollar. That's how much it would cost. Or we could get the square yards and multiply by 4. Just remember that when you're rounding, comparing the two answers you may not get, it's right to the actual whole number. And if you were to round this off to the nearest tenth, you would still get 0.6, wouldn't you? Now with this problem, we do have an area here, but we're not going to be working in square yards or square feet because our prices are in linear yards. It says per yard here, not per square yard. And that makes sense because what we're going to do is produce a border for this regular Pentagon. And we need to know how long it is, and there's a couple of steps involved. I guess probably the first thing we should do is find x. After that, we're going to have to figure out how to convert to yards, but we can probably do that. Now, this is a regular Pentagon. What does that mean? It means every side is equal, among other things. It means every angle has equal measure also. But we don't really need the angles right now. We can make use of the fact that x plus 5 equals 3x plus 19. Now we have our algebraic equation. We can subtract x from each side here, add 19 to each side here, and get that 2x equals 24, x equals 12. Let's substitute and make sure that makes sense. If x was 12 here, we'd get 17 centimeters. If x was 12 here, we'd get 36 minus 19, which I'm pretty sure is 17 centimeters also. There we go. So x does equal 12. Now we have a problem. We can easily figure out the perimeter. In fact, we can do that right now. What the heck? This is regular. They're all the same, so it's 5 times 17. 85. Okay. 85 centimeters. We still got that same problem. They gave us the cost in yards. That was nasty of them. Now what we have to do is figure out how many yards is 85 centimeters, or vice versa. For instance, we could compute the cost per centimeter here, and then just multiply by 85. Or we could figure out how many yards 85 centimeters is, and it ain't going to be much. Let's give that a try. And just lay it out. Give us a chance to do a little more of that dimensional analysis I was talking about. Now we got 2.54 centimeters per inch. Right. I'd say so. And we have 36 inches per yard. So when I multiply this out, I should get centimeters per yard. Except that Y6 doesn't look much like the abbreviation for yard to me. There we go. How about YD for yard? These two will cancel and I'll get centimeters per yard. First I got to figure out what 2.54 times 36 might be. I get 91.44, and as I said, these cancel, and we get 91.44 centimeters per yard. So we can figure out how many yards this is, or we can just compute the price per centimeter. Now let's try computing the price per centimeter. After all, there are 91.44 centimeters in a yard. So let's just divide this 150 by 91.44, and that's how much we're paying for each little centimeter. So we got 1.5. We're going to divide it by 91.44. On a per centimeter basis, fringe is going to turn out to be extremely cheap. And for this, I would use a calculator. And I get 0.0164. That's in dollars, remember? It's $1.50 per yard. So that's really 1.6 cents. But in the end, we're going to want our answer to be in dollars anyway, so there's really no point in converting this to pennies. We'll just leave it as 0.0164. And that would be dollars. $0.0164 per centimeter. Now, what we do is multiply that number by 85 centimeters. And I'll put the units in there so we can see that they cancel, and we end up with dollars. There's another job for the calculator. I get $1.4 per mat. And this is the per mat cost. And does that make sense? Well, I think so. After all, there are 91, almost 91 and a half centimeters per yard, and we've got 85 centimeters. So we're just about 6.5 centimeters under a yard. If there's 2.5 centimeters in an inch, that means we're only a few inches, 2 or 3 inches short of a yard, which means it's almost exactly 1 yard all the way around, and we should pay close to 150, and that's the answer we got. So I tend to believe this answer. Now here's one where we're going to have to remember what complementary means, what supplement means, and do a bunch of algebra too. For instance, A and B are complementary. What does that mean? It means they add up to 90 degrees. So let's set up our algebra right off the bat. 2x minus 4. That's an expression for angle A. Plus, oops, I don't need to write these equal. I should have put a plus sign in there. 4x minus 8. And that equals 90 degrees. We'll just say 90 for now. And that would be 6x minus 12. 90, or 6x equals 78. 78 divisible by 6. Let's see, that's 1, 3. Yeah, okay. X equals 13. Find the measure of the supplement of angle B. Well, let's say the supplement was called the supplement of angle B alpha sub S. S for supplement. And by definition, alpha sub S plus equals the measure of angle B equals 180 degrees. That's because supplementary angles add up to 180. What is the measure of angle B? Well, we don't know yet. We're going to have to punch that in here, aren't we? 4 times 13 minus 8. 40 and 12 is 52. Minus 8 is 44. See if that's right. It's easy to check. We'll just punch it in over here. 2 times 13 is 26 minus 4. No, that's not right at all. Let's try this again. Of course, they're not supposed to be equal. I'm sorry about that. All I can say is my neighbor's chickens are clucking in my other ear. They're so annoying, I sometimes forget what the heck it is I'm doing. These two are supposed to add up to 90. So if this is 2 times 13, which is 26, minus 4, which is 22, it still isn't going to add up to 90, is it? You know, I enjoy eating chicken a lot more than I used to. And you've probably spotted my bonehead move by now. If not, well, here it is. 6x minus 12 equals 90 means that 6x equals 102. I subtracted from both sides. I think you've seen me do this before. I do it in my head and I get way ahead of myself. But like I said, I'm going to enjoy fried chicken tonight. 102 divided by 6. Does that one work out? Yeah, I think one works out too. That's 1, and 7 times 6 is 42, right? So how about x equals 17? And no matter how many times I get it wrong, I will continue to do things in my head. I'm sorry, I'm just lazy that way. So what do we have here? 4 times 17 minus 8. That's 40. And 28 is 68. Minus 8 would be 60. 2 times 17 is 34. Minus 4 would be 30. Oh, looking much better. So I'm going to stick with x equals 17. You guys can take a vote on it. See if you prefer 13 or 17. I'm voting for 17. Which means B is this one here. So all we have to do is put that in here. We get 60 plus the supplementary angle equals 180, or that's supposed to be an S, not a 2. There we go. Now it's just a mess. Is 120. So the supplement of angle B is 120 degrees. It's actually very easy if you don't do things in your head like I do. I hope you're learning a lot by watching me make mistakes. As I've said before, it's good to learn from your mistakes. It's better to learn from someone else's mistakes. So watch me carefully. I make lots of mistakes. You should learn a lot. I think about all we're going to need for this is our distance formulas. They don't actually, when they say how much shorter, they mean in distance, not in time. They're not even giving us any speeds. How long it would take to get from one place to another. Because frequently, if we're talking about railroads, maybe this is a freeway with a speed limit of 60, and maybe these are arterials, or vice versa. But they didn't bother us with any of that stuff. All we have to worry about is the distance. Makes it nice and easy. Let's call this A, B, and C. And all we're really doing is figuring out the distance if we go straight from A to C, or if we go through B first, forming this here right angle. Well, let's take the coordinates of A. What are they? Oh, I'd say they're 2. Pardon. Is that right? No. That's x is 0, and then y is 2. So, there we go, like that. I think that's what they mean when they cross these two lines. Now over here, what is our x-coordinate? 5. Pardon me, that doesn't make any sense. A is 0.02. C is the 0.5. X is 5. Let's see here. Is that 5 also? Doesn't look right to me. Yes, it is. What is the distance from A to C? Yeah, let's try 5 minus 0 squared plus 5 minus 2 squared. That's 25. That's 5 squared, 25. 5 minus 2 is 3 squared is 9. (25) and 9 is 36, and the square root of 36 is 6. They gave you one of those easy ones. If you're not familiar with it, well, we'll discuss it more when we get to Pythagoras' theorem. But this is a very common trick to make it come out to 5 and 3, so when you square it, it makes sense. At least you get a number you can use. No, you don't. 16 and 9 is the one you normally use. Then you get 25, and that is the square. 25 and 9 is the only one here is the square root of 34. I did this once before. Just forget that one. 25 and 9 is not 36, it's 24. Wow. What about this distance here? I don't think we even need to compute this yet, because we're just going to make comparisons, right? See, about how much farther. So let's wait and see what we get here. We probably will have to convert this to something more useful. I think we already figured out that that's, you see that? That usually means approximately. I think we already figured out that's like 5.8 from a previous problem. Now I'll double check it with the calculator in a minute here. Now what about this? Well, when they're horizontal and vertical like this, we could write out the formula, x1 minus x2, but they're going to have the same x coordinates, so that part's just going to be 0. Pardon me, they're going to have the same y coordinates, so that part's just going to be 0. For the x, well, obviously it's 5. And the y part, well, y2 minus y1 is 0. The y coordinates don't change. So for this, we just get 5 squared, and we take the square root, and we get 5. So nothing more to talk about. Over here, we get 3. So that's 8 miles. It's 8 miles this way, and about 5.8 this way. Or a little over 2 miles. Shorter if you go this way. And of course, that's always going to be true. It's always less to take the straight line. How many earrings or hoops can the jeweler make? Well, what we're really going to have to figure out now isn't the area, because there's really no area to this. It's all just linear, but it's in a circle. So we have to just figure out the circumference of this circular hoop, and then we'll divide that into the 2 meters, and that tells us how many of these hoops we could actually make. Well, we've got our dimensions in millimeters, so let's convert this 2 meters to millimeters right off the bat. Why? Because it's so darn easy. Remember, 1 meter equals 1,000 millimeters. So 2 meters, and I bet I can do this in my head without making a mistake. It's 2,000 millimeters. That's how many millimeters he has to work with. What's the circumference? It's pi times d, or 2 pi r, but in this case they gave us d. Why divide by 2 and then multiply by 2 again? It wouldn't make any sense. So we have 3.14 times 25. And my calculator says that's 78.5. And what is 78.5? That is the amount of wire needed in millimeters. I probably ought to put that in there. In millimeters per earring. 78.5 millimeters per earring. So what we need to do is divide that into our 2,000, because that's how much we have to work with. This problem might seem silly, but I've worked in parts of the country where people do make jewelry all the time. It's actually a fairly common hobby in some parts of the country. And what would that be? When I perform this division, I get 25.4777, a whole bunch of stuff. Nearest tenth, 25.5. However, how many pairs of gold hoops can the jeweler make? And that's a sensible question, because they're probably going to sell them in pairs. Unless there's a Van Gogh convention in town and a bunch of people with one ear near earrings. It's almost always going to sell them in pairs. So how many pairs does that add up to? Well, we're just going to have to divide that by 2. And how much is that? Well, it's less than 13. So it's 12. Now, it's going to be some fraction over here, right? The way the question was worded, this fraction is irrelevant. Unless he's going to sell 0.5 or 0.2 or 0.3 of an earring, or 1.3 of a pair. What is 1.3 earrings worth, unless you have 1.3 ears? So I suspect the actual, answer, for instance, if this is multiple choice or something, the one they're probably looking for is 12, because that's how many actual pairs. And nobody's going to actually buy, fractions of a pair. However, the precise answer is that divided by 2, which is 2.75. Well, if you want to be precise, you could say he could make 12.75 pairs. That's not a totally ridiculous answer, because he would have 12 available for sale. He's got this amount left over here to add to his next batch. Now here's one that, on a standardized test, you may want to not spend too much time drawing pictures if you can get by without it. And here's a case where, if you understand what's going on, you might get by without drawing a picture, or at least an entire grid. You don't need the entire coordinate plane. Why not? Well, the midpoint is 4, 2, and one endpoint is minus 2, 6. In other words, we have the line segment. So what we have is a segment which we know the endpoints of, which is midpoint to A. And the entire midpoint is exactly half the length of the segment. In other words, it's a bisector. It breaks it in half. So all you have to do is compute the length from point M to point A and double it. And that should be easy to do. And let's take x2 and y2 to be A. It's arbitrary. So we have minus 2 minus 4 squared plus 6, pardon me, minus of minus 2. We square that. And that's going to give us the length of MA. Well, what do we have here? Minus 6 squared. That's 36. 8 squared. So we can put 64 down here. We want the square root of that. And, well, that looks like 100 to me, and the square root of 100 is 10. So let's just write it down here. So what's the whole length? 20 units. When you're doing these multiple choice, it's nice when the answer you get is actually one of the choices. But don't read too much into it, because they will put common mistakes in here. For instance, notice 10 is in here. When you got all done, if you forgot that you were actually computing half of it, you might see the 10 here and go, well, okay, there's 10, we're done. No. They're very good at that. They know what the common mistakes are because they give these tests to lots of students before they make them standardized tests. And they look at all the most frequently occurring wrong answers, and then they put those in too. Yeah, it's a nasty thing to do, but that's how they do it. And I like these kind of problems. They just make sure that you set up the problem correctly, and then move on. You don't actually have to go through all the boring arithmetic to get an answer. The perimeter of a rectangle is 85 feet. And remember, we have the length here and the width here. What is the perimeter? It's 2L plus 2W. What information do we have? The length of the rectangle is 4 feet more than its width. So we can write that L equals the width plus 4. We also know that P equals 85. So we can write 85 equals 2 times W plus 4 plus 2W. We multiply this out, we'll get 2W plus 8 plus 2W, or 4W plus 8. And that can be rewritten as 2 times 2W plus 4. Why in the world you would want to rewrite it that way is beyond me. Frankly, I would write it as 4 times W plus 1. Or I would just write it as 4W plus 8. So when you look over here, this one is just a rewrite of this. There's this. This is correct, but it's not over there. This is correct, but it's also not over there. We can rewrite it this way. So in this one, you'd have to come up with an answer and then look over here and see which one of these rewrites of the answer, which one of these is a rewrite of the correct answer is what I'm trying to say. Once again, they just had to find a way to waste a little bit more of your time. They couldn't make it simple for you. By now, I bet you know exactly how to set this up. Pardon me. Remember, YW bisects XYZ. All you have to do is remember what that means. It means it breaks it up into two angles of equal measure, or two congruent angles, or this equals this. We've been doing a lot of this, and we'll probably continue to do a lot of it. Algebra just tends to creep its way into almost every part of mathematics. Geometry is no exception. So we just set up our algebraic equation once again. This equals this. And now we go through and solve. We subtract 5x from each side and get an x over here. We add 9 to each side and get 11 over here. So I get that x equals 11. If I put that in here, I get 55 plus 2, which is 57. Over here, I get 66 minus 9, which is 57. So, checking our work, we have that XYZ. We checked our work just to make sure we had the right x. These two should turn out to be equal. That's why I did that. That's not the answer, though, because they want the total XYZ, which of course is 114. So 114 would actually be the answer. And here we have another one that just involves interpreting what's being written here. A and B are complements. So, let's gonna write alpha sub A and alpha sub B for angle A and angle B. I think it's easier than writing M and then the angle symbol, and then it just seems clumsy. And if there's a written version of long-winded, then long-winded. Long-winded is when you talk too much. I'm not sure what you'd call it when you write too much. But they equal, let's see, they're complements, so they must be 90 degrees when you add them up. On the other hand, we have that angle A is 8 times B. So we can write alpha sub A equals 8 times alpha sub B. So how about we substitute in there? Would that be a sensible thing to do? And we'd end up with 8 times alpha B plus alpha B. Well, this looks like it's going to be fairly easy. Now we just have 9 alpha B equals 90, or alpha sub B equals 10. Does that work? Well, I think it would. After all, if the other angle was 8 times this, it would be 80 degrees. And 80 plus 10 is, in fact, 90 degrees. So these two would be complementary. Now what they asked you for, now that we have the measure of angle B, which of course in turn tells us what alpha sub A would be also, find the measure in degrees of the supplement of angle A. Well, we have that alpha sub A equals 80 degrees, and remember, we're going to call this the supplement of it, alpha sub s plus alpha sub a must equal 180. That's what it means to be the supplement of. And this is actually 80. Subtract 80 from each side, and what do we get for alpha sub s? That would be the supplement of angle A, and we get 100 degrees. Again, just a nice, simple, one step at a time problem. Write down what you know. A and B are complements. Okay, so alpha A sub A, alpha sub B, added together must be 90 degrees. Alpha sub A is 8 times alpha sub B. So you substitute that in here, and now we've got this, which gives us a solution for alpha sub B. We use that in our next equation, which determines the measure of the supplement of alpha sub A. And it's that. Just one step at a time, and it's real easy. Don't try to solve it all at once or figure it out all at once. Remember, there are no large problems. There are just a whole bunch of small problems put together. And that's the way you should always try to break a problem down. And again, going to have to just take the problem in nice, simple steps. We have the perimeter. We're supposed to find the area. Now, right off the bat, we know that, remember the area formula for a triangle? 1/2 B H. This would be H, and this would be the base. But we don't know what they are yet, do we? No. We have to find X. How do we do that? We're given that the perimeter is 400 feet. And by definition, the perimeter is this plus this plus this. So let's just write it all out. And there it is. The parentheses are completely unnecessary. I just threw them in so that you can keep track of how we've grouped this. This is one side, this is another side, and this is another side. So if we rearrange all this, what do we got here? 1, 2, 3 x's. And we got 90 plus 70, which I think is about 160. That equals 400. So, first thing we should do, I guess, is subtract 160 from each side, and it'll give us 240. And if we divide 240 by 3, we'll get 80. X is 80. So this side here is 80. This side here is 150. 80 plus 70. Now, all we have to do is plug that back into our area formula. 1/2 of the base, 150, times the height. That's 80. And if it does any good, we could write that as 75 times 40. But I'm still going to have to grab my calculator. And we get 3,000 feet squared, which I really should have been able to do in my head. 4 times 75. That's 300. Multiply that by 10 and you get 3,000. But I did it the hard way. And here's some more of those explain problems, which they mean throw in a bunch of English verbiage. Well, okay, if that's what they want. I'll give you some hot tips on this stuff, though. I think I've mentioned it before. When you're explaining this in English, in just ordinary words, and don't try to sound like the people you hear on TV. Most of those people don't really know anything about math or public speaking. You will hear the word kind of, well, it's not really a word, it's a phrase, or kind of and sort of interspersed all through paragraphs needlessly. You'll be tempted to use those. Well, the area would be kind of, well, we need to kind of find, well, we sort of need to find. No, that's absurd. Don't say it. Don't try to imitate the people you hear on the radio or the TV. They're really not very bright. I heard one just a few days ago saying that the Justice Department told them they needed to kind of reword the question. What does that mean? You either alter it or you don't alter it. It's been changed or it hasn't been changed. There's no way to kind of change anything. So don't throw those words in there. They're just going to make you sound like you don't know what you're talking about. But do definitely talk to your instructors and ask them what kind of verbal explanations they're willing to accept. Because they'll probably be the ones. The computer can grade the multiple choice parts, no problem. But they haven't got computers that can evaluate answers where you have to show your work. And see, I think all this is just a direct result of having lawyers and bureaucrats design these math tests, because the standard phrase in math is show your work, not explain. Just show your work. You don't just write down an answer and expect the grader to give you credit for it. You have to show how you arrived at that answer. And normally you do that algebraically. Words aren't very necessary in mathematics. In fact, they're not necessary at all. If you actually understand the vocabulary and the symbols of mathematics, you can completely forget whichever language it is you normally speak. So what's this one all about? Well, an athletic director wants to put in a playing field that'll be twice as long as it is wide. And then they give you the cost of the artificial turf. So what does he have to spend on artificial turf? And the answer is 0 if he plants grass. They didn't include that in the question, so I guess we're going to have to assume that he's stuck with artificial turf whether he wants it or not. You can grow grass indoors. It's not impossible. It's really pretty easy. Grass will grow anywhere. Drop some seed on your rug, throw a little water on it. In a week or two, you'll have grass. Don't do that. Your parents will kill you. So how are we going to work this one out? Well, let's start again with what we know. We're going to have this rectangular playing field. Let's just go ahead and draw it real quick. That's a real thin playing field for skinny people. Now, it's going to be twice as long as it is wide. So let's write in W here for the width and 2W for the length. That's how we interpret that. Artificial turf cost $4 a square foot. Director has 50 grand to spend. What's the largest area you can afford to cover? Well, what we have to figure out is how many square feet can you make this. So the first thing we have to do is divide $50,000 by $4 per square foot. And if we put the dimensions in, we can see that we're doing this right, because this is $4 per, we'll say, foot squared here. And don't forget, since this is a fraction down here in the denominator, what's going to happen is this all works out to, what does it work out to? And I get 12,500 square feet. By doing it this way, you see, dollars cancel. We end up with 1 over feet squared down here, which becomes feet squared. So dimensionally, we're doing this right. Now the area, length times width, so it's 2W times W, or 2W squared equals 12,500 square feet. And we're using that because that is the maximum size field we can build with $50,000 to spend. Now this should turn out to be let's see, 6,250. And that's W squared. Well, we've got this part here for part A already. The largest area that the director can afford to cover with artificial turf. Boom, 12,500. Now, find the approximate length and width of the field and nearest, but that's the part we're doing right here. So we need to figure out what's the square root of 6,250. I'm not sure. Well, my calculator says the square root of 6,250 is 79. I'm going to assume my calculator's right. Find the width and length to the nearest foot. Well, that means the width is 79. And this, let's see, 160 minus 2 would be 158, right? Isn't that what 2 times 79 would be? So, down here, what's the largest? That's 12,500 feet squared. Find the approximate length and width to the nearest foot. And that's 79 for a width and 158 for a length. And boom, you got it all. You see, these problems, they look tough, but you really just have to just break it down one step at a time, and it's not that bad. Now here's a question which is really asking which is going to have the largest perimeter and which is going to have the largest area. Because the perimeters will determine how much black ink gets used and the circumferences here. Around a circle, circumference, around a square, perimeter. And the interior, well, that's area, and that's where the red ink is going to be used. If it was 30 circles and 30 squares, this would be really easy, because we'd only have to figure out which is greater in terms of distance around the circle or the square. Because if the circle uses more ink than the square, multiplying them both by the same number isn't going to change anything. They will still use more. But they messed us up. It's 25 squares and 30 circles. So we're actually going to have to work it all out. How are we going to do that? Well, the diameter of the circle is 1 inch. So if we add up all the circumferences, it will be 30 circles times pi times the diameter, which is 1. Fairly easy. That equals the perimeter, the circumference of 30 circles. I'll call that C sub 30. And what about the 25 squares? Well, it's just 1 times 1, which is 1. Times, it's 25 times the area of the square. But it has a side of 1 inch, so it's 1 times 1, which is 1. And that's the perimeter of the 25 squares. Piece of 25. Which uses more black ink to draw the outline? Well, I don't see where do we even need to work it out right now? Well, I don't see why. 30 is bigger than 25. We know that right off the bat. Pi is 3.14. So if pi was only 3, this would be 90 and this would still be 25. So we don't even have to do any arithmetic to figure out that the perimeter around the 25 squares is definitely less than the total of the circumferences around those 30 circles. Okay. Now, which uses more red ink? Well, here's a really dopey mistake I made. I computed the area of the squares, and I wanted the perimeter. Don't ask me why I did that. I slept just fine last night, well, until somebody wanted to use the pool table and I had to get up. So let's see here. It won't go away. It just won't go. Now it's gone. Can I do this again? Please? Give me one more chance. Now if we do it the right way, the perimeter around the square is 4 times one side, which is 4. And that is multiplied by 25 because we have 25 squares. Now that equals 100. And that's pi sub 25. And now, if you do this the way somebody who actually knew what they were doing would do it, you might really need to compute 30 times 3.14 and make sure that it's less than 100. I'm sure it'll turn out to be about 93, 94, but let's do it. So, the total inches in all the circumferences of the 30 circles is 94.2. The total inches of the perimeter of 25 squares is 100. So the perimeter of the 25 squares is actually a little bit more than the circumferences of the 30 circles. So we'll use more black ink on the squares. Well, that's the first part of the problem, which took way longer than it should have. That's the problem with dumb mistakes. You don't just get the wrong answer. You waste tons and tons of time, like I just did. Now, the red ink. Well, the red ink is what we use to color in the areas. So now we just have to figure out the total area of the 30 circles and the total area of the 25 squares. Now let's try the areas of the circles first. We'll try that. A sub c. Now it's going to be 30 times the area of one circle, which is pi times r squared. Well, d is 1. The radius is always half of the diameter. In this case, that's pretty easy to work out. Half of 1 is 1/2. And that has to be squared. So now, well, 30 times pi is 94.2. We know that from up here. One half squared is 1/4. And what does that come out to be? Well, it's about 3.5. Calculator might give you a more exact answer, but I can do that in my head at 23.5. Since we're doing this primarily as a comparison, if the numbers come out close, I may have to grab the calculator and make sure that I'm not a few tenths off. But let's see where we're at first. Now the area of the squares is what? Well, I had it once before. That was 30 times 1 times 1 equals 30. And this is feet squared. And this is feet squared. 30 is greater than 23.5, which was the area of the circles. So we use more red ink on the squares. and we use more black ink on the squares. Even though, wow, if I ever stop making mistakes, I could be a dangerous, dangerous person. This is not 30, it's 25. That means this is 25. We got 25 squares, not 30. And 25, well, it's still going to be more than I think what this turns out to be, but now that it's close, I'll check it with the calculator. And with the calculator, I get 23.55, which rounds up to 23.6, which is still less than 25. Now that's funny. Even if you made the same dumb mistake I made, you'd get the right answer. It's not going to happen very often. If we put the 25 in here, then obviously we get 25 square feet for the total area of the 25 squares, which is in fact more than 23.6. Yahoo! After a long sequence of dumb mistakes, I think we actually have the right answer. And the answer is it takes more ink for the squares either way. It takes more ink for drawing the perimeters of the squares, and it takes more ink to draw the areas. Here's a cool problem because it's very practical. If you ever do any navigating, you'll have to perform computations exactly like this. When I say navigating, you might be out hiking in the woods and just want to know when you're going to get to camp. It doesn't have to be in an airplane at 1,000 miles an hour. You can navigate on foot. You can navigate out in well, in this case, they're on a lake, I think. Isn't that what they say? Yeah, in a large lake. And you're probably doing about 3 miles an hour on a lake, especially if you're in a sailboat. What they want to know is, well, it's funny. They give you this question here, and they sort of walk you through how you're going to actually solve it. If you didn't know any of this stuff, if it wasn't there, and they just asked at the very end which boat gets there first, this is what you would do to get to it. But they're laying the steps out for you. That's good. You see it over and over again, and when you get to a point where they don't lay these steps out for you, you'll know what to do. So what we really need to do, obviously, just like it says here, find the distance to the buoy. So what is point A here? Well, it looks like it's a 1 already. And I would call that 1, 7. And let's see here. I would call this the 0.7. 5. And C, well, that's a 2. And 2. Now what we need is this distance and this distance. So let's see here. Yeah, it's probably a good place for it. AB is going to be, remember our distance formula, 7 minus 1 squared plus 5 minus 7 squared, and we need the square root of all that. That's going to be 6 squared, which is 36. It's going to be minus 2 squared, which is 4. You have to add that together and take a square root. That equals a square root of 40. And we can get exact numbers for these later. I'm just going to work them out and leave them in these terms, because there's more arithmetic to follow, and who knows, the other terms might have square roots in them too. We can do it all together. Then again, maybe not. We'll just wait and find out. So we've got the length of AB as the square root of 40. What about BC? Well, that'll be 7 minus 2 squared plus 5 minus 2 squared. We'll need the square root of all that. 7 minus 2 is 5 squared. 7 minus 2 is 5, and we square it, we get 25. 5 minus 2 is 3, and we square it, we get 9. That'll be the square root of 34. Do these answers make sense? Looks to me like AB is a little bit longer than CB, and that's what we got. So far we seem to be on the right track. Our answers are more or less making sense. Now what do we do next? Point A goes at 5 kilometers per hour. And luckily they told us this. If they didn't tell us anything, I would just go ahead and assume these were kilometers, because it would be arbitrary. We're free to count these as whatever units we want. Since they gave us kilometers per hour, I would just take these to be kilometers. But they told us they were, so that's even better. We've got our distance in kilometers. Otherwise we'd have to convert. And now we've got kilometers per hour. So how long does it take? Well, remember, you take your distance, divide it by the speed, and that's how long it'll take. So let's see here, boat A would be square root of 40 divided by 5. And that's how long, in other words, T. Sub A. That's the length of time it would take boat A to get to the buoy, is the square root of 40 divided by 5. Now, the time for boat B to get there would be the square root of 34 divided by 5.2. Well, I would say by inspection this number is bigger than this number without even using the calculator. If I was on a test, I would just go for it and leave it at that. Why? Well, remember, if the denominators are the same, but my reasoning could be off. So let's check it. I think that's going to turn out to be bigger, but I could be wrong. Let's find out. What's the square root of 40 divided by 5? And the calculator seems to agree. This number is just a little bit smaller than this one. This actually worked out to like 1.26 or 5 or 7, something like that, which rounds up to 1.3. And this one rounded down to 1.1. So, who gets there first? Boat B. He's slower, but he doesn't have as far to go. Boat B gets there first, but not by much. Well, these are in hours actually, so I said I rounded these off, so it's really like 1.5 tenths. A tenth of an hour is 6 minutes, so 9-10 minutes quicker. Actually, that is significant, isn't it? It gives him time to drink some coffee and laugh at the other guy. And that is the end of our review of Foundations of Geometry. Our next videos will be on